Now let's move on to observation number 3. So here it says, if A vector is given by A1 I cap plus A2 j cap plus A3 k cap, B vector is given by B1 I cap plus B2 j cap plus B3 k cap, and C vector is given by C1 I cap plus C2 j cap plus C3 k cap. Okay, now they're asking what will be the scalar triple product. Let's find it. First thing, just like the previous proof, we did what? We found out B cross C first. Can you tell me what was B cross C? We'll draw the determinant I, J, K, right? Clear? And what we have in here, B is first, so we will write the components of B, B1, B2, B3, right? Then components of C, that is C1, C2, C3, right? It's simple as that. Okay, now let's expand. So if I expand, so we have I cap and I, this goes away, this side, so B2, C3 minus B3, C2, clear? Minus J cap. Okay, you see all the lessons of your previous chapters is needed in this. Okay, so maths is such a subject you have to keep on practicing every single day. You cannot leave any chapter. You have to do every single one of them. So now J, this side goes, so B1 C3 minus B3 C1, then plus K cap. What do we have in here? B1 C2 plus sorry, it will be what? Minus, right? I'm very sorry. Okay, so this is what we have. So this is our dot product which we what am I saying? I'm sorry. This is the cross product which we got of B and C. Now we are into the next process, that is A dot B cross C, right? I think most of us know. I don't want to write it again. This whole thing will be too lengthy. Now if I do dot product of this one with this one, what do we have? I dot I, we already did. We are doing I dot I, that is what? 1, right? So we have A1 into B2 C3 minus B3 C2, clear? Then J dot J is 1. Now keep in mind there is a minus sign, so I will write minus A2 B1 C3 minus B3 C1, right? Now the last one, what do we have? K dot K is 1, so we have A3 B1 C2 minus B2 C1. Okay, clear? Now there is a shortcut. If I do the dot product of this one with this one before expanding only, so I dot I is 1, right? So I will write A1. J dot J is 1, so I will write A2. K dot K is 1, so I will write A3. And it will be B1, B2, B3, C1, C2, C3. If you have a doubt, then you can expand this one and you will see that it will be like this. Okay, so this is how our observation 3 goes. Now let's move on to observation number 4. Now what it says is cyclic permutation of 3 vectors does not change the value of the scalar triple product. So this is our fourth observation. Now what it says, the cyclic permutation of 3 vectors does not change the value of the scalar triple product. So it says, suppose I have a cycle like this. We have A in here, we have B in here, Let's write this as vectors, and we have C in here, right? Now if I take A, B, C, so we are moving in what? Anti-clockwise direction, right? So A, B, C, scalar product, triple product of A, B, C will be equal to B, C, A. It's the same anti-clockwise direction we are moving. So it will be B, C, A. A is equal to, again, C, A, B. C, A, B. Understood? So cyclic permutation of the three vectors does not change the value of scalar triple product. Same goes like this. If I say ACB, ACB will be equal to what? CBA, CBA will be equal to what? BAC, BAC. Please don't equate ABC equal to ACB. They are doing opposite direction, right? One is going in anti-clockwise direction, the other one is going in the clockwise direction. In the next observations, we will see the relation between these two. Okay, just for this moment, you think of ABC is equal to BCA is equal to CAB, and ACB is equal to CBA is equal to BAC. One follows the clockwise direction, the other one the anti-clockwise direction. Now let's move on to the fifth observation. Now the fifth observation says that in scalar triple product, the dot product and cross can be interchanged. So if I interchange the dot and cross product, the value of the scalar triple product will remain the same. So that's what it says. So let us see how can that be true. So if I have, if we interchange the cross and dot then the value of scalar triple product remains the same. So this is what they have said. So let's do it. So what we have, A dot B cross C, right? So this is our ABC. A, B, C, right? So now we see if I interchange the cross and dot product, so what do we have? A cross B dot C. This is it, right? But this is not the right way to write. So I will just write this one as C dot A cross B, right? And this thing is actually what? C A B. ABC is equal to CAB, right? They are following the cyclic permutation, right? And you see, if I interchange the dot product and cross product, we get the same vectors. Understood? Now we move on to the observation where we discuss the relation between the two scalar triple product. One was the anti-clockwise and the other one was the clockwise, right? So first of all, A, B, C. This one was what? Our anti-clockwise one, right? So this one was what? Our A, B, C. And we are finding the relation of this one with, what was that? The clockwise one. So it is ACB, right? Clear? So ABC. Can you tell me ABC is what? A dot B cross C? Yes or no? Yes. Now, I think we have done this one before in cross product, that B cross C, cross product is not commutative. So B cross C is minus of C cross B. Yes or no? B cross C is minus of C cross B, right? So in place of B cross C, I will write here minus of C cross B. Can I write? Now let's take the minus out. So if I take minus out, so what I get, A dot C cross B. Now this whole thing becomes what? A dot C cross B. It is just scalar triple product. So it is of A, C, B. Clear? So when you interchange the direction, the sign changes. So ABC becomes minus of ACB. Am I clear? In the same way, CBA will become minus of ABC. Understood? Clear? So that's it. Now we are with the last observation in here. So observation number 7. What is the value if we have same two vectors in a scalar triple product? It's a very interesting one. Can you guess it? Okay, I will give you 1 second to guess. Oh, sorry, I cannot get a reply. Now, the scalar triple product of this one is, I can write this one as A dot A cross B. Can I write? Yes. Now, in our observation number 5, we learned what? We can interchange the sign, right? So can I write this one as A cross A dot B? Now this is not the normal way to write. The normal way to write is B dot A cross A. I hope you guys remember. Cross product of the same vector is equal to how much? Please, don't tell me you don't know. It's 0, right? Because it's A. And cross product gives you what? A sine theta n cap. If we have the same vector, the angle between them is equal to what? 0 degree, and sine 0 is 0. So this whole thing is 0. So B dot 0 vector will give you 0. Understood? So always remember, when you have two same vectors, the scalar triple product will always be 0. Very, very important.